Hello, I'm John Manure from Accu-Slice. This video will be a follow-up to my previous video on the Automated Accu-Slice System. In this video, I've made two major changes to the Automated Accu-Slice System, designed to make it easier to use and also to improve its performance. The first change is creating a new box which contains the Nextion Display panel, the emergency stop button, and a pause button. And this box will be located on top of the Accu-Slice system, mounted on the front miter bar. This makes it much easier to use the system. The second change is by adding a bunch of additional bracing for the table and the legs on the Automated Accu-Slice system. This makes the system more stable and improves its performance. In this video I'll be describing both of these changes and also doing some additional testing to show the performance of the system. One of my concerns was the size and placement of the electronics console. This console was quite large and needed to be located either in front of the Accu-Slice system or slightly to one side of the index table. In any case, it appears it's always in the way, which required one to walk around it. I also felt that the emergency pause and stop buttons needed to be closer to the board being sliced in order to react more quickly when these functions were required. As a result, I created this new small display panel box that is mounted on the front plate on the Automated Accu-Slice Index table. This box measures 12 inches long by 6 inches wide by 1.5 inches tall and includes the Nextion Display panel, the emergency stop button, and the pause buttons. By placing these controls on top of the index table, it is much easier and more convenient to operate the Automated Accu-Slice system. The remaining electronics in the electronics console was relocated underneath the index table and totally out of the way from operations. The electronic system will be redesigned and installed in a small box which will mount on the two legs on the left side of the table underneath the Accu-Slice Index table. I could not find a suitable commercial box for this top-mounted display panel, so I custom machined this box using my CNC mill. The sides of the box are constructed with some aluminum plate. For the top, I machined a piece of dough and plastic on the mill. I machined the opening for the display panel and even machined a bezel around the screen. 2 wires or cables needed to be added. Each cable has 4 lines in it. The Nextion Display panel requires 4 of these leads on one of the cables. For the other cable, 2 of the leads are for the pause button and the other 2 leads are for the emergency stop button. The electronics and software for the emergency stop needed to be redesigned. In a previous version, the 24-volt power supply for the stepper motors was directly wired into the emergency stop. However, in order to use smaller wiring for this system, the emergency stop would now be controlled by a relay switch inside the electronics console. I also machined and added some angle blocks under the display panel to angle the display panel slightly. This makes it easier to view the display screen. This new display panel box is a significant improvement in the design of the Automated Accu-Slice system and makes it easier, safer, and more convenient to operate the system. I discovered 2 issues with the stability of the index table with the 4 support legs. While these legs did better support the system and make it run more smoothly, the legs were not stable enough to support the index table when it was removed from the bandsaw table. When I moved it off the bandsaw table, the table started to tilt in either one direction or the other. What was needed was some additional brace supports for the table. So first of all, I added this front brace, just under the index table. This brace is 3 inches wide and is screwed into the top of the legs. This brace provides a support to eliminate the tilting of the table once it is removed from the bandsaw table. I did mount this brace high on the legs, even though placing it lower would give the legs more support. By placing it lower, it would be in the way of your knees as you were using the system, so I decided to keep it higher on the system. Next, I added 2 additional leg supports on the sides of the legs. Again, these give the table legs additional support. The addition of these 3 leg supports definitely improved the stability of the index table, especially when it was removed from the system. However, the biggest problem was this thin miter bar which was used in the system. The miter bar in the hammer bandsaw is only 15 millimeters wide by 6 millimeters thick, as compared to the Laguna bandsaw and other US major bandsaws, which use a miter bar which is 3/4 inch wide by 3/8 inch thick. These thicker bars are much more sturdy than this smaller, thinner bar. On the hammer bandsaw using the Automated Accu-Slice system, this thin miter bar hangs out both sides of the bandsaw table by about 12 inches. I noticed a lot of movement with the miter bar due to this distance and the small size of the miter bar. I did see some vibration in the miter bar as the system was operating. I suspected this move would affect the operation and possibly the accuracy of the system as it was cutting boards. In the previous video, I cut several boards using this new Automated Accu-Slice system. The cuts were quite good and the surfaces were quite smooth. However, I did notice that on both ends of the boards, there were additional blade marks on both ends of the boards. The cuts were quite smooth in the center, but on both ends there were some additional blade marks. I propose this may be due to the excess vibration of the miter bar. This would explain why the cuts were better in the center of the board than on the ends of the boards. So my next project was to add some additional supports for the bracing of the miter bar. I came up with several ways to do this, but I decided to add this 3-inch wide brace that attached to the guide bar and leg support block on one end of the brace, and then is attached to the side of the bandsaw table on the other end of the brace. After machining and attaching these braces to the bandsaw and index table, the result was amazing. The system is now solid as a rock with no lateral movement of the index bar. So I just mounted a new board to this sacrificial fence on the carriage on the Automated Accu-Slice system. This was a piece of birch. It's 36 inches long by 8 inches tall by 2 inches thick. This is a fairly heavy board, comparable to what most luthiers would use to operate the system. In fact, this system was designed for a luthier. I'm making 2 of these systems, one for my own use and one for a professional luthier who wants to cut boards for the luthier market. And these boards are, usually about 8 inches wide and 30 to 40 inches long. So this is, as I said, a heavy board, and I thought I would further test the system to make sure it operated properly. One of my concerns was, were these stepper motors strong enough to operate the system? But indeed, after operating it, they were plenty strong to operate the system. So I wanted to see if the improvements in the legs would improve the performance of the system. So I mounted this birch board to the system, and I made one initial cut. And this is the board that came off the system. The results were amazing as I predicted. The attached photo compares the poplar board cut in the previous video with none of the braces or supports which I added, and then this birch board with all of these new braces and supports. I used some side lighting to accentuate the blade marks on the boards. With the addition of these braces and supports, the blade marks on the birch bar is vastly improved. In fact, the cuts are nearly identical in the center of the cuts as on the ends of the cuts. But let me go now and run a couple of boards through the system and show you how it works. So I'm now ready to cut my first board with the system. I'm using the same wood slicer blade, which is a variable 3 to 4 teeth per inch blade on the system. And I set my system up to cut at 6 inches per minute, which is quite slow. I'll be cutting a board 50,000 of an inch thick, and I set my depth of cut to 39 inches. My board is 36 inches long. It's about an inch away from the bandsaw blade, so I needed 39 inches to make sure the board fully clears the bandsaw blade at the end of the cut. So I'll just be cutting one cut here to start the system. So it's all set up. So my forward speed is 6 inches per minute. My reverse speed is 30 inches per minute. My board length is 39 inches. My board thickness I'll be cutting is 50,000 inch thick. My blade kerf is 45,000 of an inch, and I'll be one slice. So that's all 6 parameters set up on the system. As I mentioned earlier, my pause button is located here. This is the red button, and my emergency stop button is on the left here. That's the red button. What's nice about this is the pause button. If I was in the middle of a cut, I could actually stop it, check it, make sure maybe it was sawdust, clogging up the blade or something. I could clear that out. Then I could restart it, and it'll pick up just where it left off. For the actual slicing of boards in this video, I sped up this video 10 times the actual cutting speed. Again, just for viewing purposes to reduce your viewing time. Also, as described earlier, I am cutting at 6 inches per minute because I've discovered that the slower you cut, the smoother the cut. Well, that board came out beautiful. In fact, the cuts on the end are just like the cuts in the center. You can see that on the screen, but that's a beautiful board. Now, the one thing I wasn't able to do with the previous setup before I put this bracing on is I was not able to cut a board 20,000 of an inch thick. The blade actually slipped off the side just because of the vibration. Now let me try cutting a board 20,000 inch thick and see how we do. So let me go and change my dimension here to 20 thousandths. And we'll cut a single board 6 inches per minute. And I'm going to speed up the reverse speed. I can go faster than 30 inches per minute. So let me change that to Let's try 50, going real fast. That should work quite nicely. So again, my forward speed 6 inches per minute. My board thickness is 20 thousandths inch thick. My reverse speed is 20 or 50 inches per minute. And everything else is the same, cutting a single board. Well, that came out quite nice. I was not able to cut a board that thin in the past using this blade, just because of the excess vibration and the movement of this thin miter bar. But this came out really nice. Let me get some quick measurements on it. I got 24 thousandths, 24 thousandths, 23 thousandths, 22 thousandths, 22 thousandths, 20 thousandths. So again, that came out quite nice. One of the disadvantages of this system now is it's pretty much permanently mounted to the bandsaw table. A couple issues came out in designing the system. First of all, the distance between the miter bar and the bandsaw blade must be less than 4 inches. So it only fits bandsaw tables with that index, the miter bar being between, say, 3 inches and 4 inches from the bandsaw blade. The other issue, because the system is pretty much permanently mounted to the bandsaw table, it really will not work on tables such as Laguna, in which the bandsaw blade goes in from the front. The bandsaw blade needs to be installed from the side. So this really limits the number of bandsaws that can be used on. Right now, the only two I can think of it fitting would be the Hammer 4400 and the Felder Model 510. I am making this for a customer who is going to be using this on a Felder Model 610 bandsaw, in which that distance between the bandsaw blade and the miter bar is much larger, but he's going to mill out a new miter bar slot on the bandsaw table to make it fit. But with the additional bracing and everything now, it's really permanently mounted to the bandsaw table. It's not easy to remove, so you want to be able to change blades without removing the system from the bandsaw table. Okay, I just installed a 6 teeth per inch Timberwolf blade. And this is again 1/2 inch wide blade, 6 teeth per inch. I adjusted my board for the first cut. Again, I'll be cutting at a forward speed of 6 inches per minute. I'll be cutting a board about 50 thousandths inch thick. And reverse speed is 50 inches per minute, forward speed is 6 inches per minute. And I set my board length to 39 inches, so just as it was before. The only difference this time is I'm using a 6 teeth per inch blade. Well, that came out pretty good, about the same as the 3 to 4 teeth per inch, but I got a little more vibration in the center for whatever reason. So actually I got better results with the 3 to 4 teeth per inch blade, the foot slicer blade. Actually it's better than the 6 teeth per inch blade. I later discovered that the electromagnets were not operating. A wire came loose inside the electronics console. As a result, the electromagnets were not activated, and that explains why I was getting a rougher cut in the center of the board. I just did a minor adjustment on my blade guide. Just one blade guide on this side was actually hitting the blade and giving a lot of sparks. You probably saw the sparks coming off. Also, my back support was not quite against the blade, so I may be getting a little lateral movement back and forth. That may be some of the reasons. So let me give this another try, and we'll cut another board. Again, the same dimensions, keeping the same board, 50 thousandths inch thick, 6 inches per minute. Well, that came out much better. And I have mentioned this in several other videos. It's very important that your back guide rest against the back side of the blade. Because if that guide's away from your blade, what can happen is your blade can move as you're cutting, and that gives you bumpy cuts, and that's what I saw in our previous cut. But this is much better. But really, based on this experience, this cut is no better than the wood slicer blade, the 3 to 4 teeth per inch. And by going with a 3 to 4 teeth per inch blade, there's less gumming up of the blade. So really, any boards over 6 inches tall, I'd recommend going with the wood slicer blade, 3 to 4 teeth variable smooth teeth blade. That's better for cutting these wider boards. But when I'm cutting smaller boards, a lot of the boards I cut are only 2 inches tall. I probably use maybe an 8 or a 10 teeth per inch blade just to give me even a smoother cut. So I'll be testing some of that in the near future. This concludes this video on additional development and testing of the new Automated Accu-Slice system. I was originally planning on making this video a little bit longer and doing a bunch more testing of the system, actually running some boards through the system and seeing how it cuts with different size bandsaw blades and board sizes. But a couple issues came up which need to be addressed, and I'll delay the additional testing for a future video. One of the first issues that came up was with the electromagnets. I'm getting a significant amount of electrical interference with the electromagnets. When they kick off and on, I get some surges in the power, and that creates some problem with the pause button and some other features in the system. So that needs to be addressed. And that will be addressed by creating a separate circuit for the electromagnets. So with a separate power supply and a switch, everything will be isolated from the rest of the system. And that'll eliminate that problem. But in doing that, I need more room in the electronics console. Everything doesn't fit in the box, and I'm not even able to test it right now with this box the way it exists. So I am planning on developing a new box. The box will mount on the legs on the side of the system, be a much more compact and streamlined system. All these wires won't go away; they'll be hidden underneath and go directly into the box, and you won't have all these wires and cables hanging all over the place. So it'll be a much more streamlined system. I'm also going to make some changes to these stepper motors. Although these stepper motors did have enough power to power the system, I'm going to put some a little bit larger stepper motors on the system, just to make sure it has plenty of power, especially when cutting longer and heavier boards. I already made the one change here in the end. This is a NEMA 34 stepper motor. It's about twice the size of the existing stepper motor, has a lot more power, and that'll make sure I have enough power to drive boards through the bandsaw blade. I'm also making some software changes. I already made one change. I'll be having the electromagnet switch added to the system so that I can actually test the electromagnets and give me the option to manually turn them off and on also. So that wasn't there previously. And I'll be making some additional software changes as I continue to develop the system. So again, that concludes this video. Once again, thank you for watching this video. If you have any questions or concerns or comments, as always, please give us a call or drop us an email. Thank you.